Okay, today we are going to learn how to graph a quadratic function. So we're going to start off by looking at this quadratic function right here, y equals x squared minus 6x plus 8. The first question that we're asking ourselves is, does the graph open up or down? In order to figure that out, we want to take a look at a, the coefficient of x squared. If a is a positive number, if I have a positive a, then the graph will open upwards like this. Each quadratic equation gives us the shape of a U-shaped parabola. So if a is positive, I have an upward facing parabola. If I have a negative number in front of x squared, a negative a, I'm going to have a parabola that is facing down like this. So if we take a look at the example that we have, this is a positive 1 hiding in here, right here in front of x squared. So we have a parabola that is opening upwards. So the vertex of a parabola, if you remember from AG2, the vertex is either this lowest point right here or this highest point right here. It's where the curve starts to face the other direction. So if we take a look, because our graph is opening up, we're going to have a minimum here. We're going to have our vertex on the lowest point, so it's going to be a minimum. So when it says how wide is the graph compared to y equals x squared, if a is bigger than 1, it's going to be skinnier. So if we have a number like 2x squared or 3x squared, what that's going to do is that's going to give us a really skinny parabola. If we have a fraction like 1/2 x squared, that's going to make our graph a little bit wider and fatter. Remember, a negative number doesn't make it wide or fat, it turns it upside down or right side up. So here, because it's still just a plain old x squared, it is going to be the same. Because we are not multiplying it by 2 or 3, the coefficient a isn't bigger than 1 or less than 1, so it doesn't get skinnier or fatter. It's going to stay the same here. Okay, the coordinates of the y-intercept. Well, that's really simple. It's just like a normal equation where you have, y equals 3x plus 2. Here my y-intercept is 0, 2 because of the constant right here, the number sticking out that's not attached to x. It's the exact same thing in our equation. Right here, our number sticking out, our constant in this equation is plus 8. So our y-intercept here is going to be 0, 8. And that's because the constant is 8. To find the x-intercepts, well, the reason why this y-intercept is 8 is because I can plug a 0 in for x. If I'm finding the y-intercept, I put a 0 in for x, and I end up with positive 8. To find the x-intercepts, I have to put a 0 in for y. So I have this equation. Now, we have spent a couple weeks learning how to solve these equations. If it's equal to 0, then I think I can factor this and solve it. So if I'm going to factor what's left here, I have x minus 4 and x minus 2 equals 0, which means that my answer is positive 4 or positive 2. And those are my two x-intercepts. So I have one x-intercept at 2, 0, and my other x-intercept is at 4, 0. So if we think about that, if we were about to make our graph, we have an x-intercept here at 1, 2, and then we have another x-intercept at 3, 4. And that's going to create a U-shape that passes through those 2 points. The line of symmetry is going to be right in between those 2 points. The line of symmetry is halfway in between these two guys and right here at 3. So the line of symmetry is halfway between the intercepts. At x equals 3. And right here at x equals 3, that is where the parabola is going to be able to fold over itself. And it's going to have the mirror image. And I know that because I can see that my x-intercepts are mirror images of each other on both sides of that dotted line. So the line of symmetry is halfway in between my x-intercepts. So if we know that our line of symmetry is at x is 3, we know the x number for my vertex, this low point or that high point, the x number has to be 3. My vertex is on that line of symmetry right there. So I know that my x number has to be 3. To find my y number, I can just put that x number into my equation right here and see what it gives me for y. So I say y equals 3 squared minus 6 times 3 plus 8, which is 9 minus 18 plus 8, or negative 9 plus 8. That gives me y equals negative 1. So I have a vertex at 3 down 1. So now we can take the time to carefully use all of this information to graph our parabola. So I'm going to draw a nice set of coordinates, nice x and y axes. And I know a couple of the key points. If we take a look up here, we know we have a y-intercept at 0, 8. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to make a dot. That's my y-intercept. I also know that I have a x-intercept at over 2 up 0, over 3, 4 up 0. And then I also have a vertex down here at over 3 down 1. So I'm going to draw in my line of symmetry. This is where my graph folds on itself. And that's helpful because if I put a dot here, I know that I can put a dot on the other side of the line of symmetry. A good example of this would be, look at my y-intercept. That is 1, 2, 3 away from my line of symmetry. So there must be another dot 1, 2, 3 away in the other direction, right here. And now I have enough information to graph my parabola. And that is how we graph. If you have any questions, come in and ask me on Monday.